So you're out shooting a gun, a rifle, and the bullet has a muzzle velocity, which is the velocity it has right when it exits the gun, of 320 meters per second. And you fire it into a special dense material. Maybe you just shoot it straight into a tree. That stops the bullet in 35 centimeters. Okay, so here is our gun. Here is the bullet in here. So the velocity right here as it comes out the end of the gun is going to be 320 meters per second. And from there, maybe you shoot it straight into a huge tree so that the bullet stops in here in a displacement of 35 centimeters. Okay, so the first thing we do after drawing this picture is we want to know, what do we know? What are our givens? So already we identified that the initial velocity as it leaves the gun is going to be 320 meters per second. We also know that the displacement that it travels is going to be 35 centimeters. Now I see that, and the first thing I notice is that we got to get rid of the centimeters. So remember, if we convert that, it's going to be 0.35 meters. Now, for our kinematic equations, we have to know three givens. So there's a third one that we have to know. And in this case, it all rests on this word stops. And if it stops, it means that our final velocity of the bullet is going to be, yep, you guessed it, 0 meters per second. Then we have to find out what we're looking for, which will be our deceleration or our acceleration. Remember, the deceleration is just an acceleration, but negative. So once we have these givens, then we can look at our sets of kinematic equations and determine which equation we're going to use. So I would look at this and say, what equation has the initial velocity, the position, the final velocity, and the acceleration? Or I could say, well, I don't have time, so which equation does not have time in it? And that's going to be the squared equation. Bf squared equals Vi squared plus 2ax. So when I plug in my values here, I have 0 is my final velocity, 320 is my initial velocity, 2 times the acceleration, which is what I'm looking for, and then the 0.35 for my position. So the first thing I'm going to do is square my 320 and then subtract it to the other side. So negative 10,2,400 is going to be that value. And then that has to still equal 2 times A times 0.35. So then my next step will be to divide both sides by 2 times 0.35. Now you could multiply those two together if you wanted and get 0.7 and divide both sides by 0.7. But that cancels out my 2, cancels out my 0.5, and I'm left with just A. So my A value is going to be negative 146,000. I rounded to the third significant digit there. Just don't round less than that, meters per second squared. Now, a couple different questions. Should this have come out negative? And the answer would be yeah, because our bullet is slowing down. Secondly, when I look at that number, should that number have come out so big? The answer to that is also yes. If you look at the initial velocity, it is almost the speed of sound. And you say, we're going to stop that bullet or take it from the speed of sound all the way down to 0 in 35 centimeters, which is a third of a meter. Then that number is going to be extremely big. So that would be the deceleration of the bullet as a negative 146,000 meters per second squared.